Application performance monitoring helps an engineer understand what is going on with an application. An application on a single machine is often monitored by inserting bytecode instructions into the application after it has been interpreted. In contrast, distributed cloud applications with functionality across multiple servers often use a technique known as distributed tracing. Andi Grabner from Dynatrace joins today's show to explain how monitoring software is built and how engineers use it to solve problems. Monitoring is core to every business, whether the goal is to understand top-level business processes or to dissect and debug a specific engineering problem. And because monitoring is actually important at every layer of the stack, there's a plethora of monitoring tools for sale, and we talk through some of those tools. I hope you enjoy this episode today. Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. Andi Grabner is a technology strategist at Dynatrace. Andi, welcome to Software Engineering Daily.
Hey, thank you. Thanks for having me on the show.
Today we're going to talk about application performance monitoring. And every time I'm walking around the vendor booths at a conference, I see all of these tools that fall under this category of software. And so I want to break down that name for people who see it. What is application performance monitoring?
Well, that's a good question. I think, as you said, it's a broad market these days. I think it has evolved over the years. Some people in the early days were using tools like Nagios, like SCOM, using basic system monitoring tools, as I want to call it. And they also thought, well, we can also monitor applications with it, because basically we monitor the servers where applications run on. But I think it has evolved since then. I think what APM tools, application performance monitoring tools, try to do, we try to monitor the application from within the application. We're using techniques like bytecode instrumentation for Java, for .NET. We hook into Node.js. We hook into PHP. We try to figure out how to monitor other runtimes like Python. And then basically not only tell you what the performance of these applications is to the end user, meaning what's the response time of the endpoint, whether it's a REST API or a website. So what is the response time, but also trying to capture more information from within the application code. So if something is slow, why is it slow? Is it bad coding? Giving you method level details. So which method with which parameter is actually having bad performance, or is allocating too much memory, is spawning too many threads. All of these things, this is what APM tools try to provide. And I believe in the current day of age, where we're not dealing with monolithic applications anymore, but service orientation is nothing new, but microservices obviously is a cool hip term. When you talk about microservice apps, I believe modern APM tools differentiate themselves from traditional APM tools with the ability that they can trace end to end. And tracing end to end means capturing the performance of a quote unquote transaction from where the transaction starts. That's typically for end consumer facing apps, either the mobile device or the browser, and then tracing this all the way through the web servers, through the app servers, into your middleware, into your database, and stitching all of this together, and hopefully with the least amount of effort, meaning no code change if possible, And I think this is what APM, and then APM not only captures this data, but I believe, and this is what you also see on the floors when you walk through conferences, there's a lot of data obviously that we capture, and we don't want to overwhelm people with just analyzing too much data. That's why we are also applying rules and artificial intelligence and machine learning on top of this data, because what you really in the end want to figure out is, hey, we just deployed something new. Does it positively or negatively impact our end users? If it's positive, that's great. So we want to learn what we did well. If it has a negative impact, then we want to know what the root cause is. But if nothing has changed and if everything is good, I don't want to look at all this data because I don't need to.
This term, application performance monitoring, the word that is the most ambiguous in that term, term is performance. So performance can mean latency, it can mean reliability. Mm-hmm. It seems like different developers are going to define performance in different ways under different circumstances. So does a developer first need to define what performance means for a given application or for a given problem that they're debugging before they choose their tool and measure that performance? I mean, how do we come to the conclusion of what performance means in a given situation?
That's a good question. I think you're right. It really depends on the app, right? If you have a high transaction volume app and you need to process them fast because your end users demand it, or your partners that use your APIs demand a certain SLA, then performance is often defined as response time. But then on the other side, if response time is not necessarily the only dividing factor, but if it is something like resource consumption, so especially if we move into infrastructure as a service, into the cloud, where we basically need to pay for every CPU cycle, for every database query we make, for every log statement we write, I think performance becomes more geared toward efficiency in terms of resource usage. So I can say, hey, this app works really well in Amazon, and Amazon scales it up and down based on demand. And that's why I always ensure, because of the automatic elasticity, end user performance. But because I made maybe an implementation that is not very efficient, my algorithms are not that efficient, I am making too many database round trips, I'm logging too much information that I not even look at anyway, that means my application actually becomes very expensive to operate. And so performance in that respect could mean making it more efficient from a resource perspective. So to actually lower the cost of running the app. And the good thing is, and then another aspect of performance, kind of the third one, especially when we look at end user facing apps, is about the user experience and kind of the efficiency of users getting from point A to point B. A classical example is always e-commerce, obviously. So how many clicks does it take for a user that gets on my homepage until they actually give me the credit card information and until I ship the package? Or it could be other tools. If you think about tools we use in our day-to-day life, ticketing systems, Jira. If you do bug tracking, how efficient can I make my bug tracking system so that a developer doesn't spend 1,000 clicks to enter a bug? And this is also kind of performance. And performance means, what is the time and how many clicks and steps does it take for an end user to actually fulfill a task? So different aspects of it. And fortunately, I believe most APM tools capture a lot of data, and then the good ones, I believe, are also able to actually answer all of these questions, because they have with different analysis options on top, and then we can say, this is your user experience and it's impacted because of ABC. This is your resource consumption, and here are your most inefficient methods, and here is your bad performing transactions, and here is why.
As we mentioned, there are all of these tools. There's a large market of tools that do application performance monitoring. Why are there so many tools?
Why are there so many tools? That's a good question. I think there are a lot of tools out there that are particular for a certain technology. So, we know that every year we have 10 new technologies. And so there's always a good opportunity for new companies to say, we built a particular effective tool for this particular technology and we do this really well. And that's great. So, but then I think over the years, if I look back, I've been working in APM. I started with Dynatrace back in 2008. And that's been 8.5 years, almost 9 years now. And a lot of things have changed also from how easy it is for tool vendors to actually build these tools. Back in the days, I remember we started on Java and .NET. And back in the days, both Java and .NET didn't make it as easy for tool vendors to get all the data. So we had to do a lot of work to re-engineer a lot of stuff to really figure out how to get these details in a very efficient way. These days, it became much easier to develop tools. Why? Because the runtime vendors, the technology vendors are exposing APIs. New runtimes are built with the mindset, we also need to make sure we build an API so that tool vendors can easily build tools for particular use cases like performance monitoring. Right? I think this is the combination of new technologies, but also that it's getting a little easier to build these tools. I believe that's why we see an explosion of these tools.
So do applications typically log the type of information that we need for performance monitoring and we just get that information easily, or do we still have to do some of the explicit information request of the application from our monitoring tool?
So if you think about logging as like traditional what developers log out, I don't think we get all the performance data. I mean, what we get, I would say most web servers and app servers have some standard logging where you can say, I want to have a log statement for every request that comes in and also log the response time and maybe some parameters like query parameters, user agent string and all that stuff. But that just gives me the information on what is the load and do I have a performance issue, but it doesn't give you anything about the root cause. It doesn't tell you, do we have a performance problem because of a certain method that I implemented wrong or because of a database in the backend that is slow. So logging out of the box without any additional effort, if you really want to rely on logging as your way of doing performance monitoring and then feeding it into Splunk or Elasticsearch or anything like that, I think out-of-the-box logging probably doesn't give you all you need. But this is exactly the problem that APM tools try to solve. They say, we don't need a developer to add additional logging in the code because we are aware, we understand what the typical problems are in a Java, .NET, PHP, Node.js application. We know how to hook into these runtimes, and then we can automatically, without any code change, capture performance data. And with that, tell whoever needs to look at the data where the hotspots are. But traditional logging is great, but I believe if you want to just solely rely on logging for performance diagnostics, you need to invest a little bit in adding additional logging to your application code. And I think one thing that it doesn't solve is the distributed application tracing, because if you build logs in one microservice and then a log in another microservice, you also need to think about how can later on these logs be correlated, because you want to know, hey, service A called service B not only once, but 50,000 times. And that's my problem. And you only figure this out if you can correlate end to end. And that's, again, something that modern APM tools solve for you automatically.
When I'm choosing the tools for my side projects, the first thing that I look for is ease of use. That's why I love MongoDB. It is the most popular non-relational database, and it is super easy to use. At the beginning of a project, I often don't know the shape of my objects, and Mongo makes it easy to evolve the database schema as I like over time. Over time, as my project gets popular, I'm going to need to scale, and thankfully, MongoDB has built-in horizontal scalability, but configuration and database maintenance aren't really what I want to spend my time on. Thankfully, MongoDB Atlas was released in 2016. MongoDB Atlas is the easiest way to get access to MongoDB without having to run the database yourself. You pay only for what you use, from small projects all the way up to large production deployments. To try MongoDB Atlas today, go to mongodb.com/sedaily and get a free $25 in credit. Use promo code GOATLAS25 to get that $25 in free credit. Atlas is the only hosted MongoDB service built by the engineers behind the database, the company MongoDB. With Atlas, you get end-to-end encryption, you get VPC peering, you get access to the latest releases, and for a limited time, you can go to mongodb.com/sedaily, enter promo code GOATLAS25, and get that $25 in credit, and get started with MongoDB Atlas. Thanks to MongoDB for being a new sponsor of Software Engineering Daily, and thanks for being the database behind a lot of my favorite side projects in the past. We're really happy to have MongoDB as a new sponsor of Software Engineering Daily. Just talking about this idea where you get a performance monitoring tool and you've got a Rails application or a Java application just standing there, and the monitoring tool will easily hook into that and start pulling monitoring information off of it. How does that typically work? What is a Rails application exposing to the monitoring tool, or the Java application exposing to the monitoring tool? Can you explain the general contract between a monitoring tool and the thing that it is monitoring?
Sure. So let me pick Java as an example. What we do, and I'm pretty sure this is true for other APM vendors too, we use bytecode instrumentation. That means when your Java code, your class files are loaded by the JVM, we can actually intercept that class loading, which allows us to actually set hooks into certain methods that are called. So now, which methods are we interested in? For Java-based applications, and also for Rails applications, we are interested in the entry points of your transactions, which would be your servlet engine, your do-get, your do-filter, your do-post, your web service methods. So because we have a lot of experience over the years, we know which frameworks are out there and which of the methods in these frameworks are the ones that are, first executing the incoming request. So we instrument this stuff, and so what we automatically tell you is, hey, which URL requests came in with which parameters and what was the execution time. Additionally, what we can do with the same technique, with this bytecode instrumentation, we can instrument very popular frameworks like Hibernate, like Spring. We can instrument your caching layer. We can instrument your web service layer when you make calls to other services. So we can automatically instrument, and with instrumentation, I mean we put some little hooks into the most important framework methods, and then we can tell you how often do you actually call these frameworks, with which parameters, how long do they take, and is there a performance difference on how these functions behave under more or less load, or depending on the parameter that you're passing in. So this is stuff that APM tools get through bytecode instrumentation. Additionally, what we also do, all the runtimes, again, whether it's Java, whether it's .NET, whether it's Python, they all expose certain performance metrics from the runtime itself. So for instance, they expose heap information. Java, classical example. How big are my different heap spaces? How many times does the garbage collector kick in? How many threads are currently active? All of these things is additional data we capture. Why do we capture it? Because it's part of the whole picture when you do performance engineering. So it could be that one of your performance is slowing down, your response time is going down, but the root cause is because the garbage collector kicks in all the time because one of your transactions is allocating too much memory. And a real good performance management tool, a good APM tool, then not only tells you that something is slow because of garbage collection, but it also tells you who is actually allocating all these objects. And that's also what we try to solve. So we try to give you a fuller picture of everything.
To clarify what you said, so the Java virtual machine or the Ruby virtual machine, after interpreting the code of your application into bytecode, if you have an application performance monitoring tool such as Dynatrace, it is going to insert bytecode instructions in between some of the instructions of your application in order to give you high fidelity monitoring. Is that accurate?
That's accurate. And then additionally to that, again, I think this is again also true for all the APM tools. We are using interfaces of the runtime, like in Java, it's the JVM-TI, the tooling interface, where we get access to what's currently going on in the heaps, what's the heap space, when is the garbage collector kicking in, and this is what we do. And on top of that, what we at least do, and I'm not sure about the other vendors, when we see the drawback of bytecode instrumentation, if you just instrument certain methods, is that you will only see methods that you actually instrument, right? And it could be, if you don't instrument critical methods that are actually having a performance problem, you see the problem in somewhere else, maybe in the parent method that you happen to instrument. So that's why we actually combine the instrumentation tracing with snapshotting of threads. So when we see a request executing, we capture a so-called pure path. So when we see a transaction executing and we capture the entry point and some other methods like Hibernate, what we also do while the threads are executing, we capture stack traces of these threads. And then we take this information and then in the end, combine and merge it with the stuff we capture through bytecode instrumentation. And this gives us, as you said, high fidelity and high quality of data for key methods that we instrument, like the servlet layer, Hibernate, JDBC, and all that stuff. But we also, on the other side, capture performance problems in methods that we may have not thought of instrumenting yet. And because the combination of these two approaches is first of all very high efficient, and it also gives you exactly the data that you need. And I think a lot of APM tools are doing kind of this as well. But we are proud that we also came up with that approach.
Are you saying that regardless of what methods end up being called in response to a user request, there's going to be some, I don't know, is it just-in-time insertion of the monitoring bytecode, and so you will have introspection into all of those methods, or do you have to explicitly say, I want this method to be monitored? So
what we have in Dynatrace, now I have to speak about Dynatrace because that's the tool obviously that I'm most familiar with. We have a concept of so-called sensor. So a sensor defines which methods we explicitly instrument. Okay, so we have a lot of out of the box like servlets, JDBC. Our users can also add their manual sensors. It's all through configuration, no code change. However, nobody wants to instrument every method just because you want to know if a certain method has a performance problem. That's why we combine our instrumentation approach with a stack trace capturing option. So that means if you are executing a request and we're capturing the execution of these methods that we instrument, then we additionally, while the thread is running, also capture what is going on the stack. We do this on a very frequent basis. So at the end, we have our instrumentation data, and then we merge it with the stack traces we capture while these transactions are executing. And then on these stack traces, we see which other methods were actually executed, how long did they take to execute, because how often were they on the stack frame. And with that, we can tell you, you know what, it seems like your real performance problem is this particular framework because it shows always 90% of execution time. And then the user is typically happy with that because you know the performance issue. But then you can also decide, okay, if this is my problematic API and I don't have yet an instrumentation point, I can now set an additional instrumentation point to understand which parameters get passed into it. And so this is why I believe the combination of instrumentation and what we call stack snapshotting and then merging it together, then this is perfect because we see every single transaction all the time, and we also make sure that we're not missing anything that is actually a problem, even though you have not thought about instrumenting a particular method.
We're talking about this instrumentation that gets set up pretty simply. once you have an application performance monitoring tool. Is there also monitoring that has an interaction with your logging stream that is perhaps more complex to set up and maybe less reliable because you're reading from the log data?
So again, from a Dynatrace perspective, what we do, we have two approaches here. On the one side, we can instrument your common log frameworks like Log4j, Log4net, whatever you use, and then we actually capture the log message that is written to the log file from within the application, and therefore also show you the context of the code that is actually writing it. So we show you the trace that we capture and then say, hey, in this particular request of this user, this is the log message you wrote. So that's nice because you can see all of that. Additionally, what we introduced recently is because we are instrumenting a process and we know, for instance, based on our experience, kind of which log files certain application servers or web servers are writing. We can also monitor writing when these log files are written. And then we can actually also automatically parse these logs as they get written and figure out, hey, look at this, there's a severe log message in this particular web server. And this happened at the same time when we saw the response time going up of another server that actually kind of is dependent to this one. So then we can actually correlate that. And I believe this is also a nice extension to APM where tracing is great and you capture stuff that actually happens in those transactions that you trace, but there's also other stuff going on, either in some background threads that you may not trace all the time, or maybe in some other components that you're not tracing, even in other tiers, and then looking at these logs and combining that with the stuff you capture from within the application, then it's getting easier to actually figure out how do different problems in one tier correlate to another problem in a different tier. And in the end, especially in highly distributed environments, this becomes very important. But then what you really need is we call it artificial intelligence, right? We apply artificial intelligence on top of that, because eventually at some point in time, if you're talking about 10, 100, 1,000, 50,000 nodes of microservices that write log files, it's hard to manage this manually. So you need to have some artificial intelligence that makes sense out of all the data, how it correlates to each other, and then tell you what's the problem.
Okay, let's get into the distributed discussion, and then maybe you can come back to the artificial intelligence discussion. What aspects of performance monitoring have gotten a lot more difficult as our applications have become more distributed, and how has that changed the approach that Dynatrace, for example, or any other APM company has had to take in developing monitoring software for distributed applications?
I think I mentioned I joined Dynatrace back in 2008, and back then Dynatrace was already founded by its core technology, which is called the pure path. So the pure path, for me, the way I always explain it, it is the pure execution path of a transaction from its origination. And this can either be a browser, a mobile device. It can also be a batch job. It can be a REST API, but it basically purely paths. It traces the pure path from its origination through all the different tiers. And we had this technology available since the inception of Dynatrace. And the way we do it is by tag and tracing. I think that's a very common technique. That means a transaction starts at some entry point. We then give it a unique ID. This unique ID gets, for instance, put on the thread local storage in your Java.NET PHP application. So we know all the other methods that are executing on that thread, they belong to this particular transaction. If you make a remoting call via HTTP, we put that tag on the HTTP request, so it travels over to the next tier, to your next service. This service can then take this HTTP header, knows, hey, I'm part of this transaction, and then so on and so forth. And this also obviously works. So we have implementations for the major messaging frameworks, whether it's JMS, whether it's MSMQ, whether it is .NET remoting, RMI. So we basically figured this out. Now, the reason why this is so important, and I think more important than ever, because we are, first of all, we have done this over the years, we've always built connected systems, right? When you're building connected systems and they're connected through a message bus, they're connected through whatever component it is. And so you need to understand the behavior end to end, because it could be that you have a front-end service calling a backend through an orchestration engine, and the orchestration engine is misconfigured, and then the orchestration engine is doing something stupid like duplicating the calls, introducing the classical n+1 query problem between services, which we've seen. And so in order for you to understand what is really going on end to end, you really need to have the end-to-end trace. Because if you would only focus on one tier, then you see, well, I get one request coming in and I'm not a problem, because based on my view of the world, I do everything efficiently. And the backend system that gets called 10,000 times says, well, I just see that I get called a lot of times, but an individual transaction, an individual thing that I execute, I do everything perfectly fine. So this is why I think we need end-to-end tracing, because we need to understand what is happening along the flow. And especially now with with the advent of microservices, and kind of the popular thing is to build these microservice architectures where you have small units, as you know, that you can scale up and down depending on demand. And you can distribute them globally wherever you have need from your end users. This is great. But again, if you want to understand the real performance impact that you have to your end users, you really need to understand what actually happens when an end user hits your application. Do we make one service call, or does one service call end up making 50,000 service calls in the backend? And maybe it's because of a configuration issue. Maybe it's because of a proxy that is unfortunately doing a wrong redirect and then redirects to a wrong version of our API. And then we have another redirect layer that then redirects it maybe to the correct one, but we have an indirection here. And so these are the things why I believe we need end-to-end tracing. Also from a development perspective, I just wrote a blog this week, which I called Tracing is the New Debugging, which basically, it's like orange is the new black. It's tracing is the new debugging. And I'm sure I didn't come up with that term, but tracing and distributed tracing is important, because if you have an environment with hundreds of services and you need to figure out a problem, it's very hard for a developer to attach a debugger to one of the 5,000 JVMs, maybe to all of them, because you don't even know where the problem is, and then start debugging. That's why tracing, I believe, is also so essential for developers in the development cycle, but more than so in troubleshooting when something goes wrong in a higher load environment.
I did a show a while ago about distributed tracing, and I discussed with the guest this question of how does distributed tracing compare to the idea of monitoring. And what she said was that with distributed tracing, you're usually taking a much smaller subset of the transactions that are going through the system, and you're doing this occasional sampling of requests so that, at any given time, if you want to look at the health of a distributed transaction as it's passing through your system, you can look at one that maybe happened 5 minutes ago, or 3 minutes ago, or 2 minutes ago, or 100 milliseconds ago, however long you have in the intervals between the sampling. But it's a little bit different than the monitoring, the low-level like bytecode injection monitoring that we were talking about earlier, because it's not as comprehensive, and maybe you would only make it more comprehensive and you'd only start to dig in and do it on a more frequent sampling basis if you actually have a problem and you're trying to debug that problem. Is that an accurate description?
Not in my point of view. No, I mean not in my world. No, in our world.
I could be misremembering, by the way.
I don't think you misremember. I think some of the tool vendors out there, especially, you said there's so many tool vendors, and solving one problem, which is really hard, but I think we solved it, is actually doing this distributed tracing on every single transaction out there. And I know some vendors, they are falling back to sampling because there is a lot of data that you capture. And a lot of people also say, well, we don't need all the data because we only need data if something goes wrong. But I believe this also comes to a point where we've actually seen APM kind of transforming into not just doing performance monitoring and being a firefighting tool if something is wrong, but what you really want to know and what you in a microservice environment especially need to know, you need to see every single transaction end to end. Here's why. Because you are all of a sudden having a lot of components that are all fighting for the same resources, whether it is network connectivity, whether it's resources on CPU, memory that you share with other containers that run in your same kind of virtual environment, whether it is connection pools to the database, whether it's the database itself. So here's the thing. I've seen countless of examples where certain approaches to APM say, here's something slow, and I give you all the details for the thing that is slow, but there was nothing apparent on why this is slow. Now, the approach of having everything on all the time can then tell you, look at this. There's a surge in very fast transactions that are all opening up database connections to our backend database, and they're all perfectly fine because they have higher priority, but because they're taking away all of the connections to the database, or they're pounding the database with too much data, it actually impacts some other transactions. So if you do not have all the information end to end all the time, you will never really be able to actually understand the root cause of performance and scalability issues in highly distributed environments, because you are sharing your resources with a lot of other systems, and you're battling for it, you're competing for it. And therefore you need to understand that somebody might actually be impacting you. And if you don't have this level of visibility, if you don't capture 100% of transactions all the time, you may miss this. And this is also what we always try to solve from the beginning. And some vendors always say, this is bullshit. We don't need this. I'm sorry for the word, but nobody needs 100% transactions. We believe we do. And especially now with microservice environments, we see the proof that you can only understand the dynamic behavior of a complete system and how individual components compete with each other on resources. You need to have 100% visibility of the fast transactions as well as the slow transactions. And, I wrote several blogs on that, why you need to have 100% transaction visibility. And I believe, again, a real good APM tool really gives you 100% visibility of everything. Because otherwise you will only solve, 20% of your problems.
Well, our applications, as you said, are not even just distributed across like a single vendor. Oftentimes it's not even like you're just on AWS. We've got external services. We might have a multi-cloud architecture, I guess we could even be just talking about AWS. What are the kinds of steps that we need to take to monitor in this type of environment, or what are the types of steps that Dynatrace has to take to make that easy for the end user? Because I think of these distributed architectures, it sounds like there's a lot of setup involved, perhaps in monitoring that type of environment. What are the steps that you need to take?
Well, I don't think it's that complicated anymore. And again, I speak for Dynatrace, but I also want to give credit to our friendly competition out there. I think we all figured out a way to install APM products in a very easy way. I mean, most of the APM products, at least those that I know, we follow a so-called agent-based approach. That means you need to install some type of agent on your servers, and we provide, at least now I'm speaking from a Dynatrace perspective again, but I'm sure this is true for others as well. We provide automation scripts for the most common automation tools out there, deployment automation, whether it's Chef, Puppet, Ansible, you have it. So that means if you deploy an app, whether it is into the Amazon cloud, into the Azure cloud, whether you deploy it into your private cloud or into some other cloud vendor, you deploy the agent with your app, and then we get loaded in the app. And so we monitor your app totally agnostic to wherever it runs. That's one nice approach, or one nice benefit of having an agent-based approach. Now, what we also do, now again, speaking from a Dynatrace perspective, we've built very tight integrations and out-of-the-box support to automatically understanding, hey, we run on Azure, we run on AWS, we run on Cloud Foundry, we run on OpenStack or OpenShift. And because we detect that, we then tap into APIs that these environments provide, because obviously you need to have more information if you run in a certain environment, or if you run in a Docker container. You need to know what is happening in your container, but also how many other containers are actually there, and how are they communicating with each other, how are they competing for resources. But to come back to your question, the setup of an APM solution and getting these agents on your machines has really become, I would say, almost zero effort, because you just deploy it through our automation tools, or through the automation scripts, and once it's out there, these agents start collecting data and then sending it back home to your your central server. And we provide both a SaaS-based solution where you can, if you are already running in the cloud and you're happy with that and you want to have a SaaS-based monitoring solution, you just send it to our public SaaS endpoint. If you want to install Dynatrace on-premise, then you just install Dynatrace on-premise, and then these agents communicate back to the on-premise solution. But seriously, the installation effort, I think we solved this problem as an industry, to be honest with you. The only thing maybe, and this comes back to what you said earlier, the number of vendors. I mean, we see so many vendors, and some are really good in AWS, some are really good in Docker, some are really good on Java and .NET. If you think about building an architecture that allows you to go cross clouds, cross technologies, then you should obviously pick a monitoring solution that can cover the breadth of technology. Because what you don't want to end up having, 5 different monitoring tools for 5 different clouds, and then trying to figure out how to consolidate the data and kind of make sense out of it. That's why I believe vendors like Dynatrace that have been in the space for a while, we have support for all the cloud vendors. We're partnering with Amazon, with Microsoft, with Red Hat. So I think we are in a pretty good stage to give you a broad view and all in one solution.
Software Engineering Daily has 20,000 engineers listening Monday through Friday. If you are hiring, or if you have a product that you would like to get into the hands of engineers, send me an email, jeff@softwareengineeringdaily.com. This podcast is sustained by the advertisers, and if you would like to become one, or even if you're just curious and you want to learn more, send me an email, jeff@softwareengineeringdaily.com. Thanks for listening. There has been wide adoption of continuous deployment more recently. Part of continuous deployment is being able to ship a small change to a small percentage of your audience and then monitor it for a while and then gradually deploy it to more people. So in this way, monitoring is crucial to the continuous delivery, continuous deployment movement. Does that process require new types of monitoring software, or is it the same monitoring software and you're just using it in new ways?
No, well, I think this is where, again, distributed tracing comes in. So what we do, we have the ability to detect which version, let's call it A/B testing, or let's do canary releases if you have green blue deployments. Because of distributed tracing, we actually understand, hey, this transaction is currently on version A and this is currently on version B. How can we do this? Because we see every single trace and we understand if it goes through a certain code flow that this code flow is actually version A versus version B, or feature A and feature B. And this then also allows us to compare, is version A or B better? And especially now to kind of bring it to the next level, in the end, you're doing all of these things to increase things like conversion rate, to make your end users happier and more productive. So that's why we also combine this with our real user monitoring, which we call UEM, user experience monitoring. And we actually understand what percentage of your user is actually exposed to version A versus version B. And does this have any impact, A, in conversion rate, in user satisfaction, and also, and I think this is a very critical component, which I said earlier, what is the efficiency of the code execution of this new feature? Because it could be that a developer is exposing a new feature and it's greatly adopted and a lot of people are using it, but this feature is using 50% more resources, CPU, memory, network, disk utilization. So this is where then real end-to-end tracing all the time really shows its benefits, because we can tell you how many users are using version A versus version B. Has it a positive or negative impact on the end user, but also does it have the right impact on the resource consumption? Because eventually, if we all start building SaaS-based software and our business models are built on providing efficient software-based solutions, if you think about Uber, if you think about Airbnb, their software has to be efficient, because otherwise their costs for the infrastructure are outpacing the benefits they get from people that pay for the service or for the ads that they click on, whatever their business model is. So that's why I believe this new way of deployment, I love it. Continuous deployment with A/B testing, with canary releases is great. We figured out a way how to understand which user is exposed to which version, and then we break down performance based on version, based on feature, and then feed this back to the engineering team.
I have worked in some environments where the systems are so complex that it's impossible to test every potential situation, and I think this changes how you can do continuous delivery, because if you're doing continuous integration, you have really good unit tests, comprehensively testing, then it becomes safer to push something to an integration in the integration pipeline, have it run against a battery of automated tests, and then you feel comfortable deploying it to a bunch of users. But in situations where perhaps the software is too complex to have tests where you feel it's comprehensively done, or you don't have the resources to do all that testing, does that put more emphasis on monitoring, because you really have to, like, if you just do a canary release, or you deploy it to 0.1% of your audience and you're just testing it against that audience, does that put more emphasis on monitoring, because you really need to be able to see how that software is interacting with your small audience and seeing if that deployment went safely?
Yeah, it's funny that you mentioned that topic. Before we recorded this podcast, I was recording one of my podcasts, Pure Performance, with one of our partners, and I brought up the same thing. We talked about load testing and the change of load testing, and I said, I think in the future, maybe we don't need load testing anymore, because nobody can load test this, and it's much easier if you do like this A/B testing and just say, let's give it a try and then see what it is. So I think I agree with you to one extent. I think this is going to happen. I think performance engineering.
It's unfortunate, but it's just a practical reality that you can't test everything.
Exactly, and I agree with you. And I think it also, if you're aware of Gene Kim and what he's writing, and his third way in the Phoenix project is about coming into this experimentation phase. So I think we also encourage our software architects and our application teams to experiment. And one experimentation phase is also, performance is also part of the dimension that we experiment with, or at least because we have monitoring in place, we can roll out a feature, and if it is not performing well, we can roll it back or not roll forward to more people. And thanks to the monitoring data, we can also figure out where we actually have our performance issues. However, what I want to say is, and this is something that is dear to my heart, I believe we can find a lot of performance and architectural and scalability issues early in the life cycle, even without running large-scale performance tests on every single change. So I've been analyzing performance problems for the last 15 years since I've been working in that industry. And I see most performance problems coming down to a small set of performance patterns or architectural implementation patterns. And even if you have a very highly distributed system with multiple microservices, thanks to techniques such as service virtualization, you can mock away things. You can run a set of integration tests or API tests against part of your system in a virtual environment, and you can detect things like And again, it's a classic pattern, the n+1 query problem between services. I'm calling the same service multiple times thanks to a code change that I made, or maybe even a configuration change of my microservice API or my microservice framework. And so what I'm saying, I agree with you that performance engineering will shift towards production, meaning we test things out and then we figure out, did we do a good or a bad thing from a response time perspective, but also resource perspective. But I also believe we can do much better in shifting left and detecting a lot of these problems, even in highly distributed system, by testing parts of the system, by simply looking at the right metrics and looking at these metrics that will tell us in a distributed production environment what is wrong. Just what I explained earlier. We are opening up too many database connections. We are allocating too much memory, which is causing garbage collection. We are making too many round trips to other services. We're sending too many bytes over the wire because we have a very bad design of our API, or we have overloaded websites. And these are all things we can automatically detect. And this is also something that we as Dynatrace try to promote. APM is great that we have it, but you need to see it as, I always say, as a guardian from dev all the way into operations, because it allows to give feedback to developers early on. With every code change they do, they can see what impact their code has potentially in the production environment, because, hey, they added another database call. Might not be a problem for them, but if they know that their feature is called 50,000 times an hour, then they also need to factor in that this means additional round trips to the database. But on the other side, we can obviously use APM perfectly for what you said, figuring out how are features doing out there that we cannot always test. Also, because we cannot always anticipate real end user behavior. I think I've started in the testing area in my career 20 years ago. And I think the toughest part was figuring out what to actually test, because we don't simply know how our real end users are really behaving.
In your work at Dynatrace, you have seen how a company that makes monitoring software works. And I am always interested to hear about how companies that make software for developers function, how they think about product development. One question I think about is, like, when a new piece of infrastructure comes out, maybe it's Docker or Kubernetes, or maybe the next thing is serverless, how quickly do you have to ship a version of your software that can monitor that new infrastructure component?
Yeah, it's a good point. First of all, I want to make one correction. What you said, we're not just building software for developers. I believe we build software for dev, test, ops, and business, because I think that's where APM has evolved to.
Totally agree.
Yeah, more people are using the data. So Dynatrace itself, so I've been with the company for 8.5 years, almost 9, and we had a major shift in the way we deliver and develop software, and also the way we think about software delivery. I did several blog posts and a webinar series on how we actually made our DevOps transformation, how it transformed from back in 2011, where we shipped software twice a year, which was very traditional enterprise, right? Twice a year, that's good enough. How we shifted that to now deploying our enterprise software every other week. So every other week, we ship an update to our customers that install Dynatrace on premise. But we also, in our SaaS solution, we do 170 production deployments per day. Now, these production deployments, I talk about deployments. It doesn't mean we do feature updates all the time, but we have on our SaaS solution every other week a feature update, but we have a code pipeline that allows us to deploy changes within an hour if it's necessary. What that allows us is actually to be more user-centric driven or market driven, as you said, right? Because we've changed the way we develop and we think about software. We can much faster adapt to change. So you brought up a lot of technologies that you mentioned earlier, Docker, Kubernetes, OpenShift, OpenStack, all that stuff. So we actually, within Dynatrace, we have teams that are dedicated to looking into these new architectures and technologies. We then typically do some research and some prototyping to figure out what this really means. We work with customers that are early adopters of these technologies. We work with the technology vendors itself, and then build support for it. And we also architectured Dynatrace in a way that it is easy extensible. So we have concepts of plugins where you can actually plug in a new technology very easily. And very often, to be quite honest with you, very often we start with, hey, this is a new technology that we see on the horizon. We don't yet know if this is really the next new thing or if it's just a short-term hype. So we use our extension frameworks to build basic support for it, then test and validate it with our early adopters. And then eventually, if it proves out to be a new technology, we just pass it back to our engineering team that then really productizes the whole thing. But we have very fast turnaround times these days, but only possible because we ourselves went through a major transformation within our organization, where we went from agile to what we call our own DevOps best practices. In our SaaS team, for our SaaS product, we actually have a no-ops mentality. That means our system was actually built to monitor itself using Dynatrace, and then depending on the monitoring data we see, our orchestration platform that we built before Kubernetes and Mesos was actually available. So we built our own orchestration layer, and this orchestration layer automates all the stuff that a normal ops would do, like adding more resources in case we have a shortage on resources, restarting services in case there's a problem. So we automated all that. So the only thing that is really left from an operational perspective is a single runbook entry, and it says, if the system cannot help or heal itself, this is then the time when we need to reach out to our chief software architects and to our DevOps team.
Okay. Well, we're up against time here, but I want to go ahead and plug your podcast, Pure Performance, which I listen to. That's the name of it, right? Pure Performance?
It is, Pure Performance, yeah.
Okay, yes. Yeah, I was listening to it to prepare for this show, and I found it to be a good resource. And I think anybody who is in ops or who is still listening to the podcast at this point probably would be interested in that podcast. What have you learned from hosting that podcast?
Well, I've learned, and I'm not sure to which episodes you listened to, but I think my colleague Brian Wilson and I, we started a podcast. We actually were inspired by another podcast, PerfBytes. Perfbytes.com is a great podcast in the performance space, and they inspired us to do that. And so what have we learned? We have learned that a lot of people are very willing to share their experience. We also learned that performance engineering has matured a lot from we are one performance engineering team within a company, and towards performance is something that everybody has a vested interest in, starting from development, but really going into ops and also into business. That's why I was saying earlier, we don't build a development tool. We build a tool that gives you facts and measures for different stakeholders, right? Hey, our campaign is running well. We tell you that. We make that much revenue. We tell you that. But on the other side, we also tell you your method is consuming too much CPU, is allocating too much memory. So I think APM has matured. But in our podcast, I love doing the podcast because I think we all have a story to tell. We all have our individual experiences that we made over the years, and we can learn from all of them. And we can learn from those people that have been around for 20, 30, 40 years and may started their career in mainframe. We can learn a lot from them because it seems we're repeating a lot of the things that they did wrong back then. And so they solved, and now we try to do the same thing again. But we can also obviously learn from the cool new kids that are playing with the latest and greatest technology. And I think this is what I love about the podcasting, having a medium and a channel to spread best practices and educate people.
Well, I will second you on that. Andy, thanks for coming on to Software Engineering Daily. It's been great talking to you.
Thanks for having me on the show.
Software Engineering Daily is having our first ever meetup in San Francisco, January 11th at Galvanize. If you live in the Bay Area and you listen to Software Engineering Daily, please come check it out. I would love to meet you. We're We're going to have some awesome speakers. We have Pete Hunt, who is one of the early members of the React.js team, who is now the CEO of Smite. Hasib Qureshi, who has been one of the most popular guests on Software Engineering Daily. Preeti Kasireddy, who has written about her career transition from venture capital to software engineering via Coding Bootcamp. Each one of these speakers is going to give an awesome talk, and I hope you can make it January 11th at Galvanize in San Francisco. You can sign up on meetup.com. You can also find the link on the Software Engineering Daily website, softwareengineeringdaily.com. I really hope to see you there.